Hi everybody. So this is going to be a video going over some of the problems from what we've learned in Unit 7. I won't have time to go over all of them, but I will post an answer key that has all of the problems worked out. You'll want to make sure you check all your answers since there will be a Canvas quiz over this material on Friday. Okay, so the first section was radicals, and simplifying the radicals was first. So if we're looking at this one, square root of 32, we would first check to see if 32 is a perfect square, and it is not. So we would look for the biggest perfect square factor. It actually has two perfect square factors. It has 16 and 4, but you want to use the biggest. So square root of 32 can be written as square root of 16 times square root of 2. And then the 16 gets out of the radical because it's a perfect square. So it gets out as a 4. So your final answer would be 4 radical 2. Then I'll do one more because there's also the type where there's a number out front. So when there's a number out front, you just save that, and if something gets out of your radical, you can multiply those together. So for this one, bring down your 5, and then you want the biggest perfect square factor of 200. 200 has 3 perfect squares. It has square root of 4, square root of 25, and square root of 100. But we want the largest, so we're going to use square root of 100. So we do square root of 100 times square root of 2, and then the 100 gets out of the radical as a 10. So this would be 5 times 10 times radical 2, which would be 50 radical 2. Okay? In the next section, it's multiplying the radicals. So we can multiply radicals where we take what's under the radical, the radicand, and we multiply those together under one radical. I'm going to do the third problem because it has a little more going on. So in this problem, you've got some numbers out front, 7 and 3, and then you've got your irrational numbers with 2 under the first radical, 10 under the second. So for this, you're going to multiply your rational or your real numbers together, or your rational numbers out front, and then in the radical, you're going to multiply the 2 and the 10. So I just took the things in the radical, put them together under one radical, moved the numbers out front together in the front. So this would be 21 square root of 20. And then you'd look at 20. 20 is not a perfect square, but it does have a perfect square factor. So we would rewrite this as square root of 4 times square root of 5. Bring down your 21. And then the square root of 4 gets out of your radical as a 2. So it would be 21 times 2 times square root of 5. So that would be a final answer of 42 square root of 5. Remember, you can pause the video at any time. Okay, the next section is rationalizing the denominator. So rationalizing the denominator is we don't want a radical in the denominator. So to get rid of that, remember we just multiply by a value of 1. That will get rid of that radical in the denominator. So in this case, it's going to be square root of 5 over square root of 5. When we multiply those, the numerator would just be 4 square root of 5. The denominator, we can put those together under one radical, so that would be square root of 25. And then square root of 25 is 5, so we would rewrite this as 4 square root of 5 over 5. And remember, you can't simplify the square root of 5 and the 5. That's an irrational number and a rational number. You can't simplify those. If your numerator had something that was a multiple of 5, you could simplify it then. Like if it was 10 radical 5 over 5. Then you could simplify this by dividing 10 by 5 to get 2 radical 5, okay? But a problem like we just did does not simplify. Square root of 5 and 5 are not the same thing, okay? All right. The next section then we talked about was the Pythagorean theorem, and we did that for 2 days. We did just some problems like this, and then we did some application problems too. So I'm going to do the middle problem. You have to know the Pythagorean theorem to be able to do these, and you have to know that C is always the hypotenuse, always the hypotenuse. Which is your longest side. So looking at the middle one, that means my hypotenuse is 15. Now remember, A and B don't matter, so you can choose either one to be A and either one to be B. C has to be your longest side. So we would do 4 squared plus x squared equals 15 squared. And again, that's just using A equals 4, B equals x, and C equals 15. So then, working on this equation, we would have 16 plus x squared equals 225. And then if we subtract 16 from both sides, we would get x squared is equal to 209. And decimal answers are acceptable, so you would go ahead and use your calculator for that one to get your answer. Hold on here, I lost my answer key. So there we go. So square root of 209 is rounded to the nearest tenth is about 14.5. And remember, you want to do the approximately equal symbol. That's approximately, because we rounded. We did not give the exact. The exact answer is the square root of 209. Okay? All right, and then the next section is, are the following right triangles? Show your work. So for these, remember what you do is you put them into the Pythagorean theorem and see if it comes out true. If it comes out true, then it is a right triangle. If it's false, it is not a right triangle. So I'll do both of these. So to find out what to use for C, you always use the longest side. A and B don't matter. So we could say A is 7, B is 24, C has to be 25. Then we're going to check it in the Pythagorean theorem. So we're saying is 7 squared plus 24 squared equal to 25 squared. So I put that question mark to say, hey, we're checking to see if this is true. So then we do 49 plus 576 equals 625. Then we do that addition. And by golly, it is. We get 625 equals 625. So that means this is a right triangle. Yay, right triangle. Now, you probably have guessed the other one is not going to be, but let's just show the steps. So first of all, you got to determine which one would be the hypotenuse if it was a right triangle. So that would be the 7, the longest side. A and B don't matter. So I'm just going to say A equals 3, B equals 4, C equals 7. So putting that into our formula, we would get 3 squared plus 4 squared equals 7 squared. That would be, and we're checking to see if that's true, so put your question mark. So 9 plus 16 equals 49. So that would be 25 equals 49. What? 25 does not equal 49. This is not a right triangle. Okay? Then today we learned proportions, or I should say we reviewed proportions. You guys have done those before. So for the proportions, we did the equations, and then we had word problems where we made the proportions, and then we had similar figures. So first I'll just do a equation that's already made. So for this one, we want to do 8 times x plus 4 is equal to 6 times x minus 5. So you can put either one on the right, either one on the left. I'm going to put the purple one on the left. So it would be 8 times x plus 4 in parentheses. And guys, the reason you want to do parentheses is so you don't forget to distribute. And then on the right, 6 times the difference of x and 5. So now we're going to need to distribute because we can't just divide both sides by 8 and get rid of it because we have that 6 over there. So we're going to need to distribute, and we would get 8x plus 32 equals 6x minus 30. Okay? Then we want to get our variables on one side, so subtract 6x from both sides. And we would get 2x plus 32 equals, and then this is 0, 0 minus 30, negative 30. Then we would want to get our numbers on the other side, so subtract 32 from both sides. And we would get 2x plus 0, we don't have to write the plus 0 down, equals negative 62. And then divide both sides by 2 to get x equals negative 31. And remember, if you have time when you're taking the quiz or test, you would want to take that solution and put it back into your equation to make sure it works. So you'd replace the x's with negative 31 and simplify the fractions. Okay, so now we have 2 questions here. One is about, if you watched the video yesterday, Brooke is training for a marathon. You might have already seen this, okay? But I think this one's trickier than the other one, so we're going to do this one. So first you have to decide, what are you going to compare? So in this one, it's miles and minutes. So you have to make a unit ratio. Like, what do you want to do? I'm going to do miles to minutes. You could also do minutes to miles, but whatever you decide, it has to be the same on both sides of your proportion. So I'm going to do 5 miles and 42 minutes for one ratio equals 26.2 miles to x minutes. That's our unknown for the other side. So then we're still going to do cross products. So we would do 5 times x equals 42 times 26.2. And that would, so that would give us 42 times 26.2 is 1,104 tenths. Okay, and then we would divide both sides by 5, and we would get x equals 220 and 8/100 minutes. Now that's an okay answer, but a better answer would be if you change this into hours and minutes. So if you forget how to do that, you would take this and divide it by 60. So if we divide 220.08 by 60, we would get 3.668. Now, that is hours. Well, we don't usually say, I run the marathon in 3.668 hours. So instead, what you would do is say, okay, this is 3 hours. And then if you take off those 3 hours, you would have 0.668 hours. Well, how can we change that into minutes, back into minutes? By multiplying it by 60. So if we multiply that by 60, we're going to get 40.08 minutes. So a better answer would be 3 hours, or you could put the word about 3 hours and 40 minutes. or you could say 40.08 minutes. All right, last one is a similar problem. And remember, with similar figures, corresponding angles are congruent and corresponding sides are proportional. So if we look for the corresponding sides, 14 would correspond to 7, so that would be 1 ratio. And then you would want to do it the same order on the other side. So since I started with the bigger pentagon, I want to start with the bigger pentagon for my other one. So let me just grab a different color. So we want to compare the 2x plus 2 over 3. So I went big pentagon over little pentagon on both sides. Now you would do your cross products. And I'm going to put the one with the variable on the left. So it would be 7 times 2x plus 2 equals 14 times 3. And I'm noticing on this one, guys, that I don't need to distribute the 7. You certainly can. You'll get the same answer. But we could do it without a calculator if we don't even worry about distributing. We can just divide both sides by 7. That would cancel out. Oops, that's a little big. So that would cancel out the 7, okay, on the left. And then on the other side, remember in your head that 14 is 7 times 2. So we could cancel out the 7 on the bottom with the 7 from the factors of 14. And then that would give us 2x plus 2 on the left, and on the right, we would only have left now the 2 and the 3 on top, and that because the 7's canceled out, so we would just have 2 times 3, which is 6 on the top. And then subtract 2 from both sides, and we would get 2x equals 4, and divide to get x equals 2. Now remember, on this problem, if you don't like doing it that way, just distribute and do it that way. Distribute and get 14x plus 14 equals 42 and solve it from there. Okay? All right, hopefully this was helpful. If you look at the answer key after you've tried the other problems and you still need some help, please message myself or Mrs. Santilli for help. Okay, have a great day.